Hey, hey everyone. This is the group number 9, and I am Daniel Orozco. I talk about of the process capability, and the introduction for the topic is defined as a statistical measure of the inherent process variability of a given characteristic. You can use a process capability for a study to assess the ability of a process to meet specification. The example most easy to compare is this question: who requires more effort to win the World Cup? In this case, is Elton John and Leo Messi. In the example, Elton Musk, he isn't not soccer player, so he is going to be less capable to winning the World Cup. For Messi, will they will be more capable at this point in time. In so wherever requires more effort is going to be less capacitable, and the capability measures is a potential and reality. The potential and CP and PAP, the capability if the process was perfectly centered, and the PP, the best process could be. In this case, it is estimated how process capability will be, and the reality CPK and PPK, the capability requires of whether our process is centered. The current process capability relative to a specification solution. Show the reality is the hamburger of left, and this is process of meeting limit and specification, and the hamburger of the right is the reality, the specification. And talk about my partner will tell you about the topic.
Good afternoon. We are the group 9. My name is Selvin Rodriguez. My presentation is about the process capability. The process capability is used in the statistic and the other branch of science. Is needed in the process to evaluate, to analyze the variability and the central tendency, because you see in the graph minimum or maximum is used to give solution for the problem. The characteristic of the process capability is the CP and CPK, because the CP and CPK is used in the short time. Okay, is used everything the under control. the process capability is follow the normal distribution, and the finally process capability, the client's requirement. And for finally, the graph is the um, statistic belt, is also the um, roller cost in the roller coaster, is the variability, and the in the process is exactly the represent um, central tendency is the solution. Thank you. Follow the presentation with the next partner. Good afternoon.
Hello, my name is Jose Rodrigo Figueroa, and I'm going to talk you about the uses of capability process. During a capability process, we have to make an analysis. This to decide or determine if a process is capable of producing output, if we can meet or accomplish our customer requirements. This can be taken out under statistical control. When we are doing a capability process, we compare the spread of a process to the specification spread. This is determined with the upper and lower limit. When we do an capability process, we can know if we have to make a risk or we can make a decision during a process. This in order to have a better vision of our project, and if we can execute this project or we can decline if we execute it. Next, please. So I'm going to talk you about some examples. As we can know, in the top left corner, we have the upper specification limit and the lower specification limit. In the example A, we can see that this process easily meets the specification limits because the spread is in the middle of the limits. In the example B, we can see that the process completely meets the specification limits as well, because this spread is between these two limits. In the example C, we can see that this process only meets just the process because it's right in the limit of the spread. And in the D, we can see that is the process does not meet the limits, the specification limits. So this process can be taken. Now in the right corner, in the bottom, we can see a similar example. So you can see here that in the A we have as well the same car, and we can see that this process meets the specification because it's right in the middle and then do not touch the limits. In B as well, we can see that this barely but exactly knows and meets the specification limits. In number C, this meets the limits but is not right in the center, so we can say that this is in risk of not meeting the specifications but still meeting. and D is right in the middle, in the center, so there's no risk, and this also meets the specification limits. And now we continue with my next partner.
Hi, my name is Carlos Barrera, and I'm from the group 9. I'm going to talk about the interpretation or interpret the graphs of process capability. We have 3 steps. The first one is check your data problems. The second, examine the observed. And the last one is to evaluate the capability of the process. First one, we has to check the data problems. In these graphs, one is good and the second one is it has a poor fit. Why I said fit? We can see the first one has a red curve and this has a good fit with the curve. The solid bars has a good fit, obviously. But the second one, you can see one of the solid bars is so higher than the curve, and that's not acceptable. And we can see the data has a problem. We can use a tool, and the name is individual distribution identification, to determine whether you need to transform the data or a fit non-normal distribution to perform capability analysis. This is the first one step. Then we have to examine the observed performance of your process. In this graph, we have 2 problems. The red curve has 2 problems. The pointed black curve, it has only 1 problem. And then the data, it has problems too. But we can see the red curve has 2 problems. Why? Because it's going to be rejected. Why? Because the curve, you can see, is out of the LSL and USL. So this is I don't remember. This is defective product, and it's going to be acceptable. Then we see like 2 lines, red lines, 2 pointed red lines. The top of the red lines, it's going to be a good product, but if it is lower than the lines, it's going to be rejected. The red curve has 2 problems, but the pointed, it don't have. It is, I don't remember how to say it, or I don't know how to say it, but it's it's upper than the red lines. So this is going to be acceptable if the black curve don't be out of the LSL and USL. So we have a lot of spread in this histogram, and this is the second step. Now, the last one, evaluate the capability of the process. Here we have one graph, and we can see it don't going to be acceptable. Why? Because we have a lot of problems right here. First, the data. Second, the spread. The third, the curve is not centered from the LSL and USL. But if the curve go upper than the red lines. So for this process data, the CPK is less than the capability we have. So the capability process does not meet requirements. The process is too close to the lower specification limit, and it's out of the lower, so it don't going to be a good product. And the process is not centered. And this is all the steps we can follow to interpret the graphs of process capability. Thanks.
Hi everyone, hi teacher, how are you? I'm going to talk about comparison to other tools. Some tools that are related to our topic are the histograms that represent forms in bars and this gave us a first view or a panoramic view for understand the process, the distributions, and the population or whatever we are using the diagram. And another are the Taguchi loss function. These are other functions that help us for foresee how much are the losses in our project, on our goals or objectives. This this tool help us see how the loss or how are the losses we have in the timeline or in the periods of our process. And then we have the the cover and measure technique. This other technique for see the process or how good our project is going in the road. And the main question we need to have in this is what percentage of the test is complete. This helps us how compare how much we are achieve our goals. No, not like the Taguchi loss function that shows us how much we are losing. No, this helps us the percent we are complete in our time, and this is related to our topic that is process capabilities, because it helps us see how the product is going to and the final how this is going to end. And in the other diapositive, sorry, here we can see the histogram and how this looks, but this is a topic of the other group, so we don't have going to see it right now. The next group is going to present this. And this then we are going to talk about the apps or programs that are related to this. And one is the data tab. This is a program you can use for the process capabilities. This is software online and have oriented to help us with this process. Here say that analyze how your process work and benchmarking them against industries. You can put they have like Excel, like these are sheet program that put us like all in lines, and you can put the numbers or whatever the programs specify you, and this is going to calculate the graphics and what you need. And then you have the Excel, that is a speech developed for Microsoft or Windows, most of always we use this app, but there are others. We are not much popular, but are others we can use online. And this the same. You can put the information in the cells and calculate what all you need. And then we have another specific application. It is more like Excel, but it's more powerful. The SAP. The only con we can see with this is that you have to pay for the service, but it's too nice that this is oriented for engineer industry career and others. We can see here we have sustainability, and these have much programs for this area. Other is the ERP and digital core, and you can, it's like Excel, and you can have much of the programs here. They have a lot like Excel, but more advanced, and you can use it. Then this Hastings database, this is more oriented for for science and system career, but this in analytics we can search and have the programs we need for process capability. And this more oriented, have a cost, but it's better and easy to use. And that's it. Thank you for your attention. My next partner is going to expose the topic.
Hi, my name is Carlos Barrera again. Now I am going to give you the conclusion about the process capability. So, the process capability are designed to see what the process is capable of doing under controlled conditions. So the benefits of conducting a process capability study allows you to determine the short-term stability and capability of a process. The process performance studies are performed to identify how well a process that is in statistical control performs long term. So like 1 week or longer. And now we have two types of variation within the process are statistically measured. The first one is the variation within subgroups, and the second one, variation between subgroups. So the variables should include different operators, materials, tool changes, adjusting, and a lot of things that you have in your process. So we have to study to get a good process performance, the engineer must ensure, for example, the data, and I talk in the first time I pass, we can get the correct or best data that we can. Why? Because if your data vary a lot, you don't get like you can see normal the graphs or the histograms and the interpretation.
Hi, my name is Juan Gaitan, and I'm going to talk you about the conclusion. So we have three important conclusions about the entire research. First, statistics is very important when analyzing or making decisions about a process, because it allows us to decide if the process is correct and meets the necessary requirements to be successful. So maybe when we are thinking about a process, we think in everything, but we need to think necessary about the requirements to be successful. So if the requirement is too difficult, maybe it's not the right decision. Okay, then it allows us second, sorry, it allows us to save unnecessary expenses at the moment of starting to execute the process. Then it will not be so difficult to adapt the process to the real life. So when we are thinking about a process, maybe in the time that we start to execute it in the real life, it's changed everything because maybe we think about some requirements, but when we start executing the process, it may need other requirements. So when we do a good process capability, we save unnecessary expenses, and then the process will be not so difficult to adapt to the real life. And third, and more importantly, to avoid making decisions that put the application of the process at risk, and to define time and capability limits for the process to be successful. Because when we think about the process, like the image in the presentation, maybe we think that the best decision is to convert the four lines into one, but when we start to put the process in, when we execute the process, we need to define the capability limits so the process will be successful at the end. So thank you for your attention. We are group 9, and bye.